building, then we're going to go through the firewall and onto an IP network to try to do native IP from one cubicle to another. And this could happen over a virtual private network service. You could try to do it over the internet, but that's probably not a very good idea. And eventually we're going to have connections to voice over IP carriers that will carry your IP packet to the far end and guarantee the quality of service. The advantages of this story, well, we don't have a PBX in here. We're doing everything with general purpose hardware and software programs, and so this is going to end up being cheaper, and we've got just one set of cabling to go to the desktop. The negative aspects of this, well, we now have connections to different carriers. We've got one carrier providing connectivity to the regular telephone network to phone just about anywhere else. We've got a second carrier for internet, a third one for managed IP services, and a fourth one for voice over IP. We're going to need some pretty high-end technicians to keep all of this stuff working, not just, for example, the gatekeeper function inside the building, but also the connections with all of these long-distance networks. Also, we'd want to know about reliability, whether it really is a good idea to not use a PBX, but instead do this with general-purpose computers and servers and so forth, or whether it would be a better idea to put the gatekeeper function and the switch and router function inside your PBX, because then that's been designed by a company that's been in the business for a long time on dedicated purpose hardware, and so we'd have a better feeling of reliability. This is one of the issues that we discussed in the pros and cons chapter. We'll finish off this chapter with some detailed designs, if you want to call it that, and then a big picture view and a discussion of what order you might want to try to get this stuff working in. This shows a detail of connecting to the telephone network and the protocols that are used. Remember, a gateway is the box that connects between different regimes, where we've got, in this case, voice over IP communications on one side and traditional telephony on the other. And both the media has to be converted and the signaling has to be converted. So the media would have to be converted from whatever codec we're using, and if we're doing the variable bit rate or not, to a stream of 64 kilobits per second on the other side, because that's what the phone company is going to be expecting. The signaling conversion is between the H.225 call setup, this is the Q.931 protocol, and the H.245 capability negotiation on the voice over IP side versus what we do on the regular telephone network. And for those of you like details, what we do on the regular telephone network is called ISUP, the ISDN user part. And that gets communicated either over channel 24 on an ISDN PRI connection, as we discussed earlier, or we could have an SS7 connection if we wanted to. If you step back and think about this, what you'll realize is that in this scenario where we have a little island of voice over IP in our building and then we're connecting to the regular telephone system for everything else, a gateway looks like a terminal as far as your phone is concerned, because the phone is going to end up establishing a phone call with the gateway and do the capability negotiation with the gateway, and then the conversation is going to go to the gateway and it will make a phone call going out on the regular telephone service and connect them together. The protocol stack diagram just shows some of the details, and this is in relation to the OSI 7-layer reference model. On the right is the protocol stack sitting on a telephone, and in the middle is the gateway, and on the left is the telephone company's control system. So we can see that on the right we use H.225 and 245, and most of that happens over a TCP connection over IP packets that are running on a LAN Ethernet inside the building. And then on the telephone company side, the message set is the ISDN user part, and then if it's the SS7, signaling system number 7 control network, that has a message transfer part, layer 3 and layer 2, over a physical connection. This is just some details for those of you who like details. So for our voice over IP project, we're going to one Saturday go around and disconnect everybody's phones and put all of the old phones in a box and give them to the Salvation Army, and take the PBX and throw it off the end of the loading dock, and then take all new IP phones and plug them into the LAN and load some software onto some servers, and then run the gatekeeper program off of the server and install a gateway to connect to the public telephone network as on the previous slide. Not. You'd probably get fired for trying something like that. When we're first deploying voice over IP, we do not want to do a forklift change and throw away all of the existing in-building communications and replace it with something new and untested. What we want to do is implement a very small piece of the story and integrate that with the existing communication system inside the building and get all of the bugs worked out, and then grow it across the rest of the building, and then possibly try connecting buildings together. What we want to do is to interoperate the new voice over IP stuff, which is connected via LAN, and our existing telecommunication system in the building. And in this chart, we're talking about having a PBX inside the building. So if we take a look at the diagram, what we see is that we've got at the lower right side, we've got all of the IP stuff, IP phones, desktop servers, all connected together via LAN switches to a router, and we've got a server running a gatekeeper function to allow people to make phone calls from one cubicle to another, and then we are front-ending that with a gateway to be able to connect it to all of the existing stuff. At the top of the diagram is the PBX. So this is the existing technology, and we've got regular phones plugged into it. What we want to do is to deploy the voice over IP stuff in the bottom of the diagram in a small area while keeping all of the rest of it working. Now we have to connect this gateway onto the existing telephone system. Probably what we would do is connect the gateway to the PBX using a T1 inside the building. But in-building T1s are not called T1s, they're called DSXs. It's just a bit of jargon. This is when the T1 isn't running with repeaters and so forth on poles down the street. When it's just some wires inside the telephone room, it's called a DSX. And what we would do is we would have a trunk interface on the PBX and connect the voice over IP system to the PBX using an ISDN PRI connection. And then if somebody on the voice over IP system wanted to make a phone call to the outside world, they'd end up going through the PBX and then out over the existing connection to the telephone company, where we've probably got a PRI connection with the ISUP signaling on channel 24, as we just discussed. Hopefully, in the long run, we will migrate everybody over to this voice over IP system, at which point we can get rid of that, what we might slightly arrogantly call a legacy PBX, and all of those phones. And at this point, then we would have the connection directly from the gateway to the public telephone network. We don't want to pay for two of those are very expensive. So in this case, we would disconnect the DSX in-building connection and instead plug an ISDN PRI connection onto the gateway, and it would deal with the phone company directly. From the user's point of view, one of the benefits of Voice over IP is going to be the new features that are available, not the actual communications. They already got that.